Look at that. But don't be scared of them. It's just not like this. That's all. It's not your basic triangle. That's all. It looks like that. Or it'll look like that. Or it'll look like that. It's part of a bigger shape. Your aim is to break it down so it looks like that. One simple triangle. That's your aim. Let's take that one. Okay, listen to the plan. First thing that you are going to do is identify what you need to find. So I'm going to go highlight that. I want to find the length B to C. That B to C length is right here. This is the length I want to find. So I'm going to go make it into, color it in red or something, okay? Or I could call it X if I want to. I can write an X here if I want to, but I don't want to complicate things. So I won't call anything X right now, okay? I just want to highlight it for you. Now, as someone said earlier, do we have to split it up? Yes, we do, because we know that Pythagoras' theorem deals with triangles and right angle triangles. So where do we split this up? We can see that if we were to draw a line like this, we can split it up. Now we have two shapes. We have a rectangle here, okay, and it's a rectangle. Why? Because it's got right angles here. Okay, so this would be right angles as well. And we have a triangle there. And this is a right angle triangle because this is a right angle. So this would also be a right angle. So we can put the right angle in here like that. Now, I'm going to draw out this triangle here. Okay, and listen to my aim very carefully. Okay, why do I need to draw out this triangle? You might be wondering, why do I need to draw it out and why do I need to start working on this? My aim was to find this length here. This length is the same as that length. You would agree because it's a rectangle. Okay, so finding this length would be the same thing as finding that length. Okay, listen to these explanations of how you break things down. Because foundation students struggle with this. They see, if they don't see a right angle triangle like they saw above earlier on, like this, if they don't see that, they're like, nah, I'm not doing this. This is too hard. But it doesn't have to be like that. Okay, so let's go back to this. Where are we? Here we go. So we are going to find this length, and then this is the same as finding that length. Okay. Now, if you notice, this length here is part of the whole 12 centimeters, which we are told in this question. So if I was to find this length of the triangle, right, and then I can take this away from the entire 12 centimeters, so I'll do 12, take away this length, that would leave me with that length, and that is my answer, because that is the length same as that. All right, that is the plan. Okay, so we are going to draw this triangle here separately. Here, there, there. Okay, it's not that great, but there you go. Drawn. And I'm going to label it. So first thing, I'm going to start with the easy one. That's 17 centimeters. I'm going to go and write 17 centimeters here. Now, I am supposed to find this length, right? Because remember, once again, I'm repeating the plan. I'm going to find this length, and I'm going to take it away from all of that, which is 12 centimeters. And then once I do 12, take away just this part, it would leave me with this part, this length. However, I don't know what this length is right now, obviously, but I need two lengths. I've got one of them. I need to find one more length before I can use and apply Pythagoras' theorem. What about this length? What would that be?
It's going to be 15.
Very good. That would be 15 because that is 15. So we are going to write here 15 centimeters. And now look, this is now a question that is asking us to find this side here. And it looks just like the questions we have been doing all lesson, where we're given two sides and we have to find the third side. We are given two sides and we have to find the third side. All right, so now we're going to label it A, B, and C. All right, here we go. So we're going to call A squared plus B squared equals C squared, and C squared is always the hypotenuse, the longest side. So it's going to be our 17, And A and B could be 15 or this side here. Let's just make it simple. Let's call this one A, this one B. And now we're going to go and apply it in our theorem. So A squared is unknown. You don't know it. All right, because that's A squared. It's unknown. B squared is 15. So there we go, 15 squared. C squared is 17 squared. And now we're going to rearrange it. So we make A squared the subject. So we're going to take this 15 squared, this plus 15 squared, away from this side. So we're going to take away 15 squared. And it's going to go here, 15 squared minus 15 squared. So we're going to have 17 squared minus 15 squared. And then we're going to go calculate that. So 17 squared, you could use your calculator here. All right, it's 289. 15 squared is 225. And then we're going to do 289, take away 225. And that's A squared is equal to 64. Of course, we're going to square root this answer. So the square root of 64, that gives us A as 8. Now, what was 8? Well, let's do 8 centimeters. 8 centimeters was this length right there. So this is 8 centimeters. Therefore, this is 8 centimeters. But we were doing this so that we can take it away from this entire 12 centimeters. So the next step would be to do 12 centimeters, take away the 8 centimeters, and that gives us 4 centimeters. So this is 4 centimeters, and therefore B to C is also 4 centimeters. So we write B to C is equal to 4 centimeters. And that is your answer. So as you can see, this is a Pythagoras question that is not so straightforward. It's not just one simple 2D diagram where you just put your values in. You've got to do a little bit more outside of the box thinking. But this is a blueprint for you on how to break down these types of problems.